Hello everyone. Today I'm going to present our paper on enhancing immersive sense making with case-driven recommendation queues. Let's dive in. Currently, we are going through the peak stage of the information age, where we are constantly overwhelmed with data, both relevant and noise. Making sense of them can put a significant overload on our cognition. Piroli and Kurd defined sense-making as an iterative loop where you constantly get feedback from previous steps as you move forward. The more effort you put on the task, the more organized your dataset becomes. This complicated and iterative process roughly boils down to two subtasks: foraging and synthesis. During foraging, you are gathering data and filtering relevant essential information while discarding the noise. During synthesis, you are synthesizing the information you have consumed so far and getting ready to present a coherent story to an audience. Now, there are two big challenges. First, users have to deal with a lot of information in a sense-making task. Sometimes there isn't enough space to even see them all at once. Lyle et al. Addressed that challenge by proposing the use of immersive space, which is a virtually unlimited space in the 3D environment offering embodied cognition, where you can organize your documents and interact with them with controllers or hand gestures. But one problem still remains. Even if you can see all of the information, you still have to go through all of them to find out what you are looking for. What if you didn't have to do that? We already saw that foraging and synthesis are intertwined with each other. What if, based on how you synthesize information, the immersive space to think could predict what to forage for? We propose using the gaze data to get an understanding of what user finds interesting during their sense-making. We chose to use the gaze because it's the most accessible and non-invasive way to infer users' perception. We developed a metric called gaze score to predict users' perceived interest in a complex task such as sense-making. We ran a feasibility study last year that showed the user's self-reported relevance aligns with the gaze-derived relevance of words and documents. In this work, we want to see how to leverage this gaze-derived interest to help users in the foraging step. To do that, we developed a recommendation model facilitated by analysts' gaze data. Let's walk through the data flow to understand how this works. First, the analyst reads new documents from the dataset and reviews old documents from evidence file. Based on the gaze data during their reading events, the system can develop an interest model for the analyst. The interest model then is fed into the recommendation engine, which also has access to all the documents in the dataset and the evidence file. Out of those documents, it generates a curated list of recommendations for the analyst to look at. Now here, the analyst interest model is composed of two things. One is global interest and the local interest. Global interest helps users find documents similar to their overall interest in the dataset, while local interest helps users find documents that are similar to a specific document. Let's see how these values are calculated. The recommender keeps a local interest vector for each document that contains the local gaze score for all words in the vocabulary. The recommender also keeps a global interest vector with the global gaze score for each word. Let's say we want to measure the local and global interest of document D with respect to document 1. Taking a cosine between the local vector of D and the global vector would return the global interest of that document. Taking a cosine between the two local vectors would return their similarity with each other. The average of the similarity and the global interest would return the local interest of document D with respect to document 1. This process ensures that the analyst can dig deeper into the storyline of one document while also being closer to their overall interest. Now that we have the interest model, the question becomes how to convey these values to the analyst. We implemented two visualization queues to convey the global interest. We wanted to guide users' attention to the most interesting documents in a meaningful yet non-intrusive way. We used color for that purpose. The more important a document is to the user, the brighter the green is. We also sorted the unread document list in a decreasing order of the document's interest, so that the most interesting document is always on the top. For the local interest for each document, the system recommended up to 4 documents with the highest local interest. We showed them as overview tabs instead of the whole document to make sure the environment doesn't get cluttered. The tabs showed the keywords and the global interest of the document through color. If the recommended document was already read by the user, the tabs also had a yellow border around them. We hypothesized that these rationales would help the users build trust in the AI. The tabs are interactable by the user. The user could review the position of a read document by hovering over the tab, which would spawn a temporary red arrow. Or they could click the tab to retrieve new documents. In both cases, clicking the tab would spawn a more permanent thin stretchable thread to connect the two documents. We wanted to see how these case-derived recommendation queues affected users' task performance, their sense-making strategy, their mental effort, and overall user experience. We ran a between-subject user study with 26 participants with two conditions, one with case queues and one without. We used the Atlantic Storm dataset with multiple plots. It had 111 documents, 65 of them were essential, which means they were relevant to the ground truth. The rest were distractions. To ensure a consistent starting point, all users started with the same 4 essential documents, which also helped building the recommendation model. The users could create notes, make labels, and search keywords in both conditions. Here are the findings from our study. Let's validate the interest model first. We found that when sorted by global interest, the top 15 documents were almost always essential, leading to near 100% precision. For documents ranked lower than 15, the precision dipped at the last leg. Interestingly, around the same time as when the experimenter rang the 30-minute bell of the 45-minute session, that time check may have made the participants search for documents random, leading to lower precision. The local recommendations were also good at guiding users to essential information while discarding distractors. We achieved 90% precision across all participants with 43% recall. The low recall meant that the local recommendations were good at discarding distractors, which sometimes led to missing some essential information as well. In contrast, freestyle participants mostly relied on search to get new information, and it did not help them in filtering distractors, leading to only 67% precision. The results reflected in the user's reading pattern as well. When compared with freestyle, we found that overall, the IST participants were efficient in filtering distracting data from the dataset, and they spent more time on reading essential information. We wanted to investigate whether the gaze cues helped users in exploring different plot lines. Here is a heat map of all the documents read by all participants, colored by the number of readers for each document. The documents are sorted by their similarity to the starter documents. The relatively pale top right corner reaffirms our finding of IST participants avoiding distractors. Upon further investigation, we found that IST participants had some bias towards starter documents. We see that many of the essential documents that are read by most participants are also closer to starters. Digging deeper, we found that all those documents were about one particular suspect who was mentioned once in the starter and happened to have the most interesting plotline. Despite being more efficient, IST participants reported lower attention and lower system performance than the freestyle participants. That made us look at how the participants used the recommendation queues provided to them. Looking at the freestyle participants, we found that they relied on search results to get new information. The search was based on keyword matching, which was straightforward and predictable. IST participants, on the other hand, relied more on the list of unread documents than search or local recommendations. That implies that IST participants prefer the global interest queues more than the local ones. In the post-study interview session, they mentioned that the local recommendation overview tabs contained sometimes vague and disjointed keywords, which made them confused and created distrust on the system. They also felt that the recommendations were often limiting their search criterion and they wanted a more diverse set of recommendations with the ability to intervene as they wish. Based on users' feedback, we proposed a set of design guidelines to improve future human-centered AI systems for immersive analytics. We believe such systems should focus on adding more context to the recommendations while covering more diverse plot lines. They should also allow the analyst control over the appearance and parameters of the recommendations for more effective human-AI collaboration. Thank you for listening. Please feel free to contact me with any questions or collaboration ideas. Enjoy the conference.